Temperature effect in resistor. We know the resistor has a temperature effect and its resistance is varying with the temperature. When you increase the temperature, the resistor resistance could be increased or could be decreased, depend on the types of materials. So in this graph you can see that the temperature, with the temperature, resistance is increased. We pick a straight line from this curve using the straight line law, because we actually dealing with some range of temperature from 0 degree Celsius to 1 degree Celsius. So using this straight line law, we can find just like this. From here, this is the resistance in 0 degree Celsius, and this is certain point. It could be any temperature above 0 degree Celsius. Suppose this is 100 degrees Celsius. So we are dealing between this range. Depending on the conductor's type, suppose metal or non-metal conductor, the temperature coefficients of resistance alpha, which is expressed in per degree Celsius, this alpha could be positive or negative. For example, this platinum, silver, copper and iron, all these metals conductor, and then the resistance of this type of metals shows the positive temperature coefficient PTC, and the value is showing here. You can see the resistance of these types of metal conductors is increased with the temperature. That is why it is positive temperature coefficients. Those types of materials have the positive temperature coefficients. So what about the carbon? Carbon is a non-metal conductor and it has negative temperature coefficient, which is NTC. So the graph is like showing here the resistance of carbon material, which is like decreased with the temperature. As soon as the temperature is increased, the resistance of those type of material is decreased. So not all the conductors we find are showing the positive temperature coefficients. So some conductors have the negative temperature coefficient. To deal with the temperature coefficient of a resistance, the equation is RT is equal to R0 1 plus alpha T. So this is equation 1, where RT is the resistance in certain temperature, and then R0 is the resistance in 0 degree Celsius temperature, alpha, the temperature coefficient, and T is the certain degree of temperature. So let's see one example, and then you will get a clear understand that how important the temperature coefficient in resistance. In this example, suppose you have a resistor which value is like 220 ohm in 20 degree Celsius temperature. say this is in room temperature, the resistance is 220 ohm. So what could be the changed for this resistor in 80 degrees Celsius temperature? So we can easily find the changed using the equation, using this equation 1. So first we have to find the resistance in 0 degrees Celsius temperature. So in 0 degrees Celsius temperature, the resistance will be R0 equal to RT divided by 1 plus alpha T. Suppose the temperature coefficient of this resistor is 0.0005 per degree Celsius. So from this equation, I put like 220 degree, which is the RT in room temperature, and after calculation it is 217.82 ohm. So the RT we have found 217.82 ohm. So using this same equation one more time, we can actually find the changed in 80 degrees Celsius. What could be the value in 80 degrees Celsius? So again, using this equation, so R80 is equal to R0 is 217.82, 1 plus alpha is 0.0005 times T is 80 degrees Celsius. After calculation, I found it is 226.53. So you can see that the change in 80 degrees Celsius, this resistor value is changed to 226.53 ohm. So in change of temperature, the resistance also changed. So it is so important when you apply the resistor in certain circuit. If the circuit you use in like high temperature, so you have to think about the temperature coefficient, and then you have to calculate the resistance value like that using this temperature coefficient, and then choose the appropriate resistor for your circuit diagram.